now is probably one of the hardest things you're going to do in this standard, and that's Hess's law. Basically the theory behind it is that you can break any reaction down, whether it's combustion, formation, whatever it is, into constituent reactions. So, for example, if I was to burn carbon completely, I'd make carbon dioxide, and that normally generates, it's about 380 kilojoules per mole of energy. If I was to partially burn it, I'd make carbon monoxide. Then if I was to burn the carbon monoxide and oxygen, I'd make carbon dioxide. If I add the enthalpies of those two reactions together, carbon to carbon monoxide and carbon monoxide to carbon dioxide, if I add those two enthalpies together, that equals the same as going from carbon directly to carbon dioxide. So you can break any reaction up into the bits that make it up. And this is Hess's law, basically. And it's covered quite well on page 68 in Continuing Chemistry, where it shows exactly that reaction I've just talked about, with carbon dioxide, carbon monoxide, and carbon. This, however, is what an NCEA question is going to be more like. So this is the sort of thing you're really going to be facing. And you'll see there's not a lot of equations given. So one of the key things that you need to be able to do is turn these little symbols into equations. And that'll actually get you to achieved level nearly. Just actually saying what those enthalpy things mean. So that would always be our first step. So rather than it being the enthalpy of combustion of propane, which is what I've got on this line here, we'd actually write it out. So what I'm going to do is I'm going to delete that, rub it out I should say, and say what it actually is. So combustion, the little C means combustion, means the reaction, states of matter are important, the reaction with oxygen gas to make, if it's complete combustion of an alkane, you should know that it only makes CO2 and H2O. Now the H2O has to be liquid because this is assuming it's standard conditions, and at 298 Kelvin, water is a liquid. We know that in reality if I was to burn this it would make steam, but we're going to ignore that detail. Okay? It's not even an assumption, it's what we do. So I'm just going to balance it. 1, 2, 3 carbons, so 3 carbon dioxides. 3, 5, 8 hydrogens, so it'll be 4 water molecules. Then I add up my oxygens on the right hand side. 3 times 2 is 6. We've got 10 in total, so 5 oxygen molecules over here. Okay, so now I've got the equation for the enthalpy of combustion of that. I've actually got my first contributing factor to answer the question, but also to show the examiner I know what I'm on about. Okay, so I'm going to start getting at least my achieved for this, even though it's a really hard question. The next one has got a little F, which means formation. So I'm not going to get rid of my water, because it's got to be formed, and I can only make one of them. So I'm not allowed to put any numbers in front of that. Formation means making it from its elements, so that's hydrogen gas and oxygen gas. So H2 plus O2. I can see that's not balanced. I need only one oxygen atom, so I need half a mole of O2.
Isn't that a highly explosive reaction?
It can be. Yeah, it's quite an exciting one to do. Don't be sorry. So now I've got the equation they gave me, the two of the three that I have to work out. And what I've got to try and do is combine these three equations. So I need to try to combine them to get the enthalpy of combustion of propene. And propene is CH2, CH, CH3. And again, if it's combustion, it's with oxygen. It's got to be complete combustion, so carbon dioxide and water. And it's telling us that the enthalpy of combustion is negative 2058 kilojoules per mole. So it's already told us the answers. It's actually a proof. I haven't balanced this yet, so let's do that quickly. 3 of those, and this is only going to be 3 H2Os. So we have a slightly different number here. So we've got 3 plus 6 is 9, so I need 4.5 oxygens. Now what I tend to do is I look for things that are in common. Okay, so I look for things that are already on the correct side, because it means I don't have to manipulate that equation much. So if I have a look at the CH2, CH3, the propene, I can see that's here. So I can just copy that equation straight in. I only need one of them, because there's one here and one here. However, this one has also got hydrogens in it, and this one doesn't. So that's going to cause a bit of a problem. So I need to get rid of those hydrogens somehow. I also have a look here, there's 4.5 oxygens here. Well, that's similar to 5, so they're probably going to be together as well. They may not be though, so I need to really think about that. Now I'm looking for things that I need to get rid of. So if I follow this reaction through, I've got hydrogens I have to get rid of, and it's made propane. Propane's nowhere in my final equation. So I need to get rid of this and this if I'm going to copy that equation in. If I also copy that equation in, I now have propane on both sides. Well, if it's a product and a reagent, then it doesn't need to be in the equation if they're in the same number of moles. So actually, they're going to cancel each other out. Here I've got 5 oxygens, that's too many. So I need 4.5, so I need to get rid of half of them. Well, I can see a half here, but it's on the wrong side. If I add these together, it would make 5.5. So you can see I put the line under it, so it's almost like a mathematical thing. So I'm starting to see the clues for how to answer it. So I'm just going to move the board across and show you how I would actually approach this question. Okay, my way of doing a question like this is I start with the equation I want at the top. And I'm hoping that I'll make it down the bottom as well. So I've got my CH2, CH3. Sorry, 5 there. Okay, so that's the equation I'm after. That's what I want to make. The first equation I'm going to copy down, because it's got stuff in there that I need, is this turning into propane, because it's got propane on the left-hand side as a reagent. So, and I'm going to put the enthalpy over here. I haven't done anything to it, so I just copy that value in, which was negative 2220. Sorry, wrong one. Negative 124. Now, this has allowed me to tick that one off, so I'm just going to put a line through it, because I've got it. But it's given me nothing else from that equation at all. It's also given me things I need to get rid of. But actually what I'm going to do first, I'm going to try to just get the things that are in there. So the next equation I'm going to try and look at is one that's going to give me my products, my CO2 and or my H2O. So I can see that there is an equation there which combusts propane, not propene. And again, I haven't done anything to it to get my 3 carbon dioxides, so therefore I can just put its enthalpy there as well. So I haven't done anything to it. Negative 2220 kilojoules per mole. Now, you can see as well as that, what's quite convenient is that it's allowed us to have a propane on the left and the right. Well, if it's on both sides, they cancel each other out. So neither of them will be in my final equation because they're on both sides. So now all I've got in there that's a problem is I've got a little bit too much oxygen, I've got hydrogen I need to get rid of, and I've got one too many waters. Well, the equation I did have was H2O plus half an oxygen makes H2O. Well, that would add an extra oxygen over here. That would make it, an extra water over here. That would make it 5 waters. So instead, I'm going to unform. I'm going to break hydrogen, water apart into hydrogen and oxygen. So I'm actually going to turn it around. H2O liquid becoming H2 gas and half a mole of oxygen gas. So I'm going to unform it because I need to get rid of one of them. So by unforming it, I need to change the enthalpy from being exothermic to being endothermic. So it's now going to be positive 286 kilojoules per mole. Conveniently for this, look what it does. Hydrogen here, they're gone. Fantastic. 5 O2s and half an O2 here is going to end up being 4.5 O2s over here because they'll go. So cross that out and that becomes 4.5. So I've taken half off both sides. 1 water here, 4 waters here. So if I take 1 water off both sides, we've got there. And then we just add these together to make sure that it has actually worked out. Okay, so here's our O2 and here's our H2O. So let's put them together. CH2, CH3, gas. The states are important. Sometimes a product might be not in its standard form, so you need to allow for the, they might give you the enthalpy of fusion or something like that, or the enthalpy of vaporization as well, that you might need to account for. Just be aware of that. Going down here, I've got 4.5 oxygens. Coming down here, 3 CO2 and 3 H2O. So this equation is the same as the top equation. So I know that I've done my working with my equations correctly. I've eliminated things correctly and all that. If this is the same as this, then I can do the next step with a lot of confidence. All I do is add up this right-hand column. Negative 124 minus 2220 plus 286. And if I do that on a calculator, I should end up with negative 2058 kilojoules per mole. And now I've proven that answer. Okay. By doing it like a mathematical process where I'm adding everything up and thinking of this arrow as an equal sign in maths, it's actually basically like working with simultaneous equations. Okay? So if you've got a mathsy type mind, think of them as being very similar to simultaneous equations, where you're trying to eliminate things, unknowns, things that don't matter, in other words, off both sides. And that, in a nutshell, is Hess's Law. That's a typical example that you'll get in NCEA. Okay? They may not give you the answer. They may say, find the enthalpy of combustion rather than prove what it is. But it's those steps. Identify what it is that you're actually trying to find. So they won't always give you the equation. They might ask you, it'll be an enthalpy of combustion or formation that you need to find. Write it down, then find what things the equations you do have in common with those, and how they can help eliminate the things that don't appear in your final answer.